All right, so I think 30-ish minutes, maybe.
Yeah.
All right.
35.
Okay, and I'll give this back to anyone who doesn't ask any questions. So that is my plan. So let's get going. I have no idea how long this will take because Jouni set up me so nicely that I unhide some of my slides, and so Sakke will throw something at me at around 10-minute mark.
Yes. Anyway,
When
even if you have stopped.
Yes, thank you. Okay, so let's start. So my name is Jukka. I was speaking here last 2 years ago, so in the last Zero to Hero event, and in the next day I changed jobs, so I kind of have high expectations for this meeting already. For the past 2 years and a month or so, I've been a senior DevOps specialist at OP Pohjola, a financial or the bank in Finland, or the financial enterprise in Finland. I'm currently there as a cloud operations lead developer, and you can very much put the air quotes kind of around the developer because I don't do any development. It's a nice word of basically hand-waving architect. So what I'm mostly doing is basically trying to figure out that what's happening around me, because it's basically a development side is like 3,000 people. There are several hundred people around the Azure platform area. So it's a full-time job to basically trying to understand what's happening inside the house, not to speak outside the house. So that's basically mostly my kind of job description, at least the one I tell myself. The leadership might have different view on things. And as a reminder, so I want to tell you as well, so I do have some Azure certifications, and if you don't know, then 3 big Azure certifications are going to retire next summer. That's Azure Developer, AI Engineer, which has been around for like less than 2 years now, and then Security Engineer. Then some other data stuff, which you can ask data people from. But so you know that those are going to be replaced with something that starts with AI. So please act surprised. That's maybe kind of myself. Why I went to a big company, of course, or enterprise, is that the company I'm now working for is doing a kind of big transformation to cloud, partly from another cloud, but also from the on-premises to Azure. And so having done this kind of platform side of things for a few years before that, I kind of wanted to have the full experience, so to speak. And boy, did I get more than I asked for. And so we are going to talk about Azure platform in this kind of regulated industry, and basically the topics are, so why are you, as in we, making things so hard for you, as in developers and other guys? So basically, things are pretty kind of hard at the receiving end of these kind of big enterprise platforms, and I kind of want to shed a bit light why they might be so hard. So another topic is then that why are we making things so hard for you? Why can't we make nice things? Why can't we do, for example, platform engineering? So basically have a button, you press the button and magic things happen. Well, that's a bit harder than it sounds. So we'll shed a bit of light at what I think that the life of a application development team might be like. And then that especially from the angle of infra as code. So basically when you are setting up the resources, well, you basically run whatever you run in app services, AKS, storage account, databases, whatever. So why doing infra as code is hard, and then spoiler alert, I'm going to talk about artificial intelligence because that's what all the cool kids do this day. They also might do their slides with artificial intelligence, and then they figure out that the slides are not actually very good, and then panic mode, and then you redo your slides in the last evening. So expect some surprises. I want also to make a hat tip to an ex-colleague of mine. So some of you might have seen the talk by Jonas Wesley from Azure on the good enough security for Azure PaaS application, which I think is an excellent talk. Not sure if there's a recording of it, but at least there's basically a blog post by Jonas on the topic. So in where Jonas basically explains what's the kind of let's say sweet spot between security and usability, both for the developers and kind of ops people. And I agree a lot with what Jonas says. So this is from his slides. So basically what you see there is application gateway before app service and web application firewall there to block some things that come from the internet or from the user side. You see Entra ID, identities. You see that he has put only the necessary things in virtual private networks. So the connection between the app service and SQL. There's nothing between the storage account and the app service, but the normal kind of security measures, because storage account, for example, has its own firewall level, the software firewall level, and then there's key vault, and then there's a app insights and mention of AMPLS, which is the Azure Monitor Private Link Service for those who don't know. So I agree with that. However, the industry I'm working has a slight disagreement with this one, and that's the topic here. So, if we then start looking at why things are hard, for example, in financial industry, especially in this kind of new age of cloud platforms. So if there are any major kind of transformation happening, there's one overarching theme, and that is the Digital Operational Resilience Act, or DORA. So that's the EU level kind of law for the financial institutions on kind of how we should do our stuff. So that's basically a risk-based approach, which tells us to manage risks, avoid any unnecessary risks, and then for example manage the third parties like cloud providers. So what is expected from for example banks when we operate in kind of cloud provider space? It touches things like identity management, security very heavily, then networks as well. And there's lots of things around incident management and incident reporting. So it basically tells us that if we have major incidents, we need to report those on the proper authorities, for example. And then it tells us how it thinks we should prevent those major incidents. So basically, the funny thing there is, of course, that it doesn't exactly say what to do. It just implies it really, really, really heavily. Then basically there are things like European Central Bank, which doesn't itself do these, but it kind of acts as a supervisor. So ECB is basically the party that supervises us, and then it audits us. And oh boy, does it really audit. I mean, those are like 4-month-long trials on how we have done the things that the regulation asks us to do. And I mean, whereas before maybe these kind of, we've had there's specifically nothing new in those regulations. It is like your basic ITSM, so IT service management, ITIL, that kind of stuff, change management, problem management, service management. It just tells us to now you really have to do that. There's nothing new in the sense of networking, because in on-premises there's always been networking. There's nothing new, well, there's something new in the security because security keeps evolving. But it tells us to do kind of proper things, but it also tells us that unless you do these things, we might take your license away, which is a kind of a big thing. So we really are kind of held accountable there, which, don't get me wrong, I think is a great thing for the kind of financial industry in Europe, but it's one of the reasons why things might appear a bit hard. There are other authorities, national authorities like the Finanssivalvonta in Finland, and then a lot of other authorities like, let's say, Traficom and those from whom we have to report certain kind of incidents. I don't know all the authorities. I'm not paid for that, but there are plenty of them. Then there's the other side of the table, which is basically the different Microsoft frameworks, and you can add mentally other, for example, security frameworks here. So there's like the Microsoft Cyber Security Reference Architecture. There's the Microsoft Security Baselines. Then less security focused, well, still pretty security focused things like the cloud adaptation framework on the overall architecture of enterprise platforms. There's the well-architected framework on how you should implement your workloads. Security is one pillar there. There are 4 other pillars as well. I don't remember them all, so let's not go there, by heart at least. And then there's a lot of other kind of consonant soup, so that's the AI version of how it feels. At least for a guy in a suit. Guy in a hooder or this kind of shirt might take it a bit differently. We are way below that desk. Then just maybe one example on what kind of things there are. So this is from Dora directly. So a sound network and infrastructure management structure using appropriate techniques. It's kind of vague, but it says the magic word network. And it continues. Second, Article 9.4, second subparagraph. So design the network connection infrastructure in a way that allows it to be instantaneously severed or segmented. So that's way more deeper. It still doesn't really say what to do, but it kind of gives this mental idea that you have to be able to kind of isolate, for example, workloads. So if there's like ransomware incident or something, you have to be able really fast to kind of isolate them on the network level, so the contagion doesn't spread from one workload to another. So when you give these kind of texts, and there's even kind of more text from the ECP level, a kind of how-to guides on how to do these things, then basically what happens that especially the network people kind of take them as 10 commandments. Like, okay, this is what we know, this is what we do. It basically says to us that please put everything in private networks. How many of you have to work with private networks in Azure daily? Lucky you. The rest of you, just wait. What's that question?
Well, I mean the second subparagraph kind of heavily implies that you need to implement microsegmentation inside subnets.
Yes,
correct?
it does. It's also the macro segmentation. So you need to have a firewall and something like hub and spoke. So you have one cutoff point, but it does heavily imply the micro segmentation. Yes, which we are getting to. So are we on board so far? All right. Then let's go through some of these things. And these are just kind of things I kind of picked out of my head. So there's things like minimize the risk of unauthorized access. So yeah, no public endpoints. That's the first thing. That's the first thing on the sliding path to kind of enterprise architecture. Again, that instantaneous severing to prevent contagion sounds like hub and spoke firewalls, and yes, NSGs didn't want to put anything there. Then segmentation, dedicated admin networks, which basically means that you have segmented office network, segmented non-production and production networks. So basically it quite straight tells you that you need to have your production workloads in a separate network, which is kind of hard to reach. So it's basically, it doesn't directly say jump machines. There are some kind of ways around that, like Bastion and things like that. But it tells you to put those production workloads in basically another network. So you are having at least 2 networks probably. One for dev and test, or the so-called non-production workloads, and one for production and maybe Q&A, however your company feels about that. Just-in-time access, so no permanent role assignments. So everything is more or less time-bound. I might have the strong authentication. So just-in-time, no permanent assignments, privileged identity management, strong authentication. I picked MFA, which probably needs to be said aloud. Conditional access policies, of course, authentication in the application side as well, but I don't know about that stuff too much. But the beautiful thing here, of course, is that basically Microsoft and Azure basically have something for everything, every one of these. And so when you are implementing platform or dictating that, then the good thing is that you have everything available. The bad thing is that then you want to use everything. So the result might be a bit complex. Then if you are a platform engineer, a application architect or developer, then basically the end result is that you have those commandments and then you obey. It's basically, it's not a discussion at this point. You don't get to do these kind of non-networked things. Because you have to remember here that when you are talking about enterprise scale, we are talking hundreds or thousands of applications and hundreds of application teams. So basically, in order to make things scale, you want to have everybody doing basically the same things. You don't have snowflakes unless it's any service. Then you can have snowflakes, but you don't really want to have any snowflake applications. So application developers would very much want to have those, and with good reasons. But basically, when you look at this from the enterprise or platform level, everything needs to be kind of the same on the platform level and control level. So what's then the impact of this in basically for the platform design? Well, you get things like subscription democratization. I'll come back to that shortly. It's a cloud adaptation framework thing. You have network segmentation. You have segregation of duties, so no kind of dangerous work combinations. You don't get access anywhere. You get only the access you need, and you get the least privileged access to where you need. So surprise, no more contributor roles, for example. You basically get contributor roles that are strangled. There are some actions that are removed there. For example, network appliance. You don't get to do, for example, your own application gateways anymore. Somebody else does those. They are basically a platform level thing that we then hand to you. Those kind of things. Because if you get access to provisioning your own network devices or appliances, chances are that you can circumvent some of those controls that we have. And that's not something we want, because we need to have that one choke point. So that's the reason why we don't allow some things. Limitations on what roles you can give, of course, because nobody wants somebody else to be able to give owners somewhere, and those kind of things. Then there's disaster recovery security. There is all the ITSM stuff, but those are not basically interesting in this scope. But just know that there are a lot of those. All right. So then it ends up with something like this. So if we think about this picture, and this is very, very simplified. So basically, when I'm talking about subscription democratization and subscription vending, they are the cloud adoption framework things. They mean that basically what we want to do is we want to hand to the application team something that's called landing zones. In this case, application landing. So landing zone basically is let's call it a product. It is something where we define the kind of basic things that everybody needs. Because we are in network, it needs to have network connection to the hub. So there's a VNet, and it's automatically connected to the virtual one in the so-called central kitchen or the platform. There are the basic role access things, let's say access packages, and then roles given to different security groups, for example. There's the privileged access management. So for example, anything contributor related, again, not the whole contributor, but some of it, that is basically behind a privileged identity management. So that needs elevation, and the elevation needs basically reason. So you have to get, for example, ticket number or something when you elevate yourself to do something in portal. Then there's a subscription. Subscription is basically the building boundary here. And what it leaves, the green thing here is basically the application side then. This is where you get to the micro-segmentation side. So typically the application teams are, well, this is the gray area, might be responsible for creating their own subnets in that VNets that given, and then the network security groups and network security group rules. So basically that's the micro-segmentation part. You get to decide how you want to split the stack of your applications. Some resources need their own subnet, like app service needs a dedicated subnet, some don't. And then basically because everything is inside virtual networks, you need to create private endpoints for pretty much everything. Then as an kind of application development team, you don't only have to understand how to provision the application resources, but also the kind of this level of networking stack. The other option would of course be that when we provide the landing zone, we already basically create you the subnets and we create you the NSGs. But the problem with that is that then when things change, how do you actually do that change? When you do it, for example, with parameter files and redeployment. And that's the kind of questions. There are pros and cons on both approaches here. But we kind of have to understand that the first impact to the application development team is that you really kind of have to understand these things when you are provisioning resources. Then, if we look at the impact on app design, the first thing you might notice is that for somewhere things suddenly appear. So there are Azure policies. So what you might not do unless somebody documents it, or you might not know unless somebody documents it that usually when we talk about private endpoints networking, those private endpoints need private DNS records. So basically, the other resources and you as a developer can find your Azure resources from the private network space. So typically, there's an Azure policy that basically figures out that, hey, somebody provisioned a private endpoint for a storage account, then the policy picks it up and it magically creates a DNS record for it. And when you remove the private endpoint, it cleans up. So it is basically nice. What you have to know is that it might take up to 10 minutes for that to happen. So if you are doing a Terraform deployment or something and you kind of are scratching your head that, okay, it seems to go fine, but nothing is working, then that's one reason. Wait 10 minutes, and then basically the DNS is working again. Then there are things like Logantics workspaces. So it's a common pattern that the Logantics workspaces, for example, for metrics or application logs are centralized. So they are somewhere in the central kitchen. For example, logs might go to Sentinel. And that is basically the security operations apparatus that sits on top of a Logantics workspace. So another policy that sets for all the resources diagnostic settings that ship those logs and metric to some place which you probably don't know anything about and might not have rights to read it. So that's again something that just magically happens, and then the result here is basically for the application team, how do I do network? Where did that come from? Your Terraform might ask that as well. So there suddenly is on second round of Terraform, there are diagnostic settings on a resource, and that's basically shows up in the plan. Why cannot I? So we took away your right to do something. If you are savvy enough to do those network appliances, you want to do NAT gateway or something, you might not be able to do because we don't let you. Sorry, I guess. And I have no idea what's happening, and that's usually the policies. So that's kind of the problem space here. And then if we look at the bigger picture here, so when we think about this kind of big enterprise area, so you have your landing zone here, but then, like I said, you might have traffic from outside, so you might want to have an application gateway and web application firewall, or Azure front door. So at least the pattern I've seen recently is that basically you get an application gateway landing zone, which is a nice word for a resource group with application gateway, web application firewall, and associated resources, and then you get rights for that resource group that sits up there. Then you might have basically some other landing zones, maybe your own, maybe something you are integrating to. Let's assume there's no API gateway in between, so you're directly integrating to it. And then you might, for example, have a shared data platform where you have those data products. I think that's a Databricks icon, I'm not sure. At least Draw.io thought it was, so maybe. So in there, what you basically get is you get your own Databricks or something, and then there's another platform team that basically takes care of the hard stuff, so the networking. So they are basically a platform running on top of platform. And that actually makes things easier for you because the kind of space where you live, what you can and have to affect is a lot smaller. That's also why maybe the AKS or Kubernetes might be a smart thing to do in this size of thing, because when you have a dedicated team that basically runs the Kubernetes cluster, it kind of makes the problem space for your developers smaller. Of course, in some sense, it also makes it bigger because then you have to understand something of Kubernetes internals usually, because somebody has to debug those things. But that's in a big picture. And then in the middle, there's the kind of really simplified gray box, which is the platform network and other platform components. And the problem here is that you have green there, orange there, but you don't necessarily have any visibility on what connects them. So let's say that there's a production firewall there, you probably don't have rights to read that production firewall. So how do you know when something doesn't work? How do you know that you need to open something in the firewall? Or as we call it, ticket ops, you have to ask somebody to ask it for you and first explain it to them so they can open it for you. And that's the kind of platform engineering problem space there. So how to kind of make those hard things, if not disappear, at least make them run a bit smoother. Am I 26 minutes on already?
Correct. Yeah.
This is going great. All right, then let's speed up. Infra as code. So traditionally, when we talk about infra as code, it is this kind of artisanal, organic IAC that requires some kind of DevOps unicorn. That's what I used to do. I haven't gotten around it lately. But basically, typically, when you are setting up an application, you basically need that guy. And when I say that guy, I point, for example, those Jura guys there who do this for a living. So basically, you know, somebody who actually knows about those Azure services, knows about Bicep, Terraform, whatever is the language's choice. And here we get to the AI part. So I think the current state of basically Copilot or whatever you are using is that actually it is starting to be good enough with IAC. It might vary with the different languages. It is arguably better with Bicep than Terraform. I think I'm a Bicep guy, so I'm pretty predicted with that one. But I think we are getting there where the AI actually does good enough implementation of those with some caveats. What it doesn't do is it doesn't know anything about your platform or the guardrails. So it doesn't know about the networking, it doesn't know about the fancy policies you have. It just merely hacks away and does the kind of bare bones implementation and then figures out, okay, looks good, it builds, doesn't deploy. And then it goes on to basically this trial and error like your junior dev. And it actually is pretty good on the trial and error part. So if you let it run long enough, it might figure things out, but it takes time. So in a single application team scope, I think you can use AI to complement infra as code. Having AI understand about documentation, I mean, it might actually do a good job about it. But it doesn't really scale up unless you figure out a way to distribute those documentation to multiple teams. So basically, that's how I imagine myself a year ago. It's striking resemblance, isn't it? All right, sorry. If somebody wanted to take a pic, go ahead. It's a horrible AI image. I don't apologize for it. All right, then the next one. So then when we kind of scale up to the platform engineering part, so where actually some team should make life easier for the application team, then what it used to require is basically a horde of platform engineering unicorns. So these guys who actually kind of know how the services work, know how to do infra as code, and also understand the networking parts of it. You might cheat with a third-party platform, partly. Not naming any names, but something like Massdriver, Humanitech, Spacelift, or especially in Terraform base, so-called tacos things. Because they basically take care of like storing the state file for you, and they provide way for kind of doing a modularization of that code on your behalf. So I assume they are pretty good about it. I haven't really used any of them. But the fact is that writing that reusable infra as code, it is pretty hard. So for example, if you're an application developer, writing and maintaining your own NuGet package, it is actually pretty hard. So you need to do versioning, you need to kind of figure out the update paths and so forth. And especially the maintenance is pain. And it is pain even with an artificial intelligence. So if you do a module of Terraform or something, it might work. And then you basically start getting these questions that, hey, why doesn't it do this? Can it do this? I have a slightly different use case for it. No. And then the implementation is the 20% that you only mentioned, and the maintenance is the rest 80%. Burning out is somewhere included probably. So instead of kind of handing, for example, a blowtorch in the sense of AI to your developers, you might want to give them, let's say, a set of Duplo Legos instead. And this is where things like Microsoft Azure Verified Modules come in. You're welcome, Microsoft. It's a free plug. So the verified modules are basically Microsoft-curated resource-level modules that are quite flexible. They are not the silver bullets, but they probably are better than what you or I can come up with myself. So that might be a thing to try unless you already have. But then comes a thing of hardening. So if you are using those, you quite soon figure out that when you use those AVM modules with an Azure policies, the problem is that the modules allow configuration that the policies do not. So you happily let yourself or AI implement stuff, and then you figure out that later that basically I cannot. It implements public endpoints. We don't allow public endpoints back to the drawing board. So it's kind of this same trial and error again. So you might want to consider implementing something like FAUG pattern on top of the AVM modules. So basically in Bicep, you have a Bicep module that then calls the AVM module, and it basically is something like this. So you call an AVM module there, and this is totally AI generated, by the way, so it might not work. Please don't take a picture, or do take, I don't care. But you set some properties, basically hardcode them that you never allow public network access or never allow public access, only HTTPS, minimum TLS is 1.2 and so forth. So you basically harden the modules that you then publish to the kind of application teams. It again comes with some downsides like really big ARM modules that are produced, but that's life. Then there's the paranoia mode, air gapping, for example. So if you don't know, you can basically cache your AVM modules to your own private registry, which means that the Bicep modules, basically, you can push them to Azure Container Registry. They are just text files. You can set up your own private registry and not use the Microsoft public registry. I think preferably by making a workflow where you push those modules there with adequate security controls. So you do kind of all kinds of security scanning before you actually kind of release them internally. It's a lot of work, but it kind of sort of works. Or then you could do your own FAUG modules and Bicep private registered modules, but yeah, let's not go there because it's getting way too complicated. Then let's do it this way. So Azure MCP server actually is pretty good with Bicep. So especially if you could give those platform guardrails for it as a skills or instructions prompts, whatever is the word of this week, that probably changes next week. When they kind of describe the AI, how the platform works. So for example, there are these kind of policies. You don't do private DNS zones, you don't do private DNS records. You basically don't do your own local antics workspaces and so on. Then it kind of speeds up that trial and error cycle quite a lot. And because the MCP server actually has intimate knowledge of the AVM module, so it understands the code, it understands the parameters and documentation, and it can also read the Microsoft Learn docs. It is actually pretty good, I would say. I mean, I'm sure it does errors, it doesn't work in every scenario, but so far what I've tested, and That's not too much because of the current work I'm doing, but I'm suitably impressed with it. It cannot brew coffee though it claims to know what the best blend is. So when I'm talking about those platform kind of documentation for the AI, it might be something like this. So for example, in here in the microsegmentation, you might want to tell the AI that whenever you are creating a subnet, you need to create a network security group, and then you have to have these rules with these priorities. So that already helps quite a bit. So there's deny all rule, but then it allows, for example, all the HTTPS and DNS traffic on the egress somewhere, so things actually work. And then the application team likely can tell that, okay, we want to use MS SQL Server, so do allow the SQL Server port to this subnet as well, and so on. But that's what I think where we are going with the kind of spec-based development. Then I'm over time, so because Jouni set me up so nicely. So the Azure SRA agent, I hope it's great. I think it's GA now. The sad thing about this for the enterprise is that it doesn't yet support private networking. So basically, I'm waiting for it to do, and I think it's in the roadmap, but it kind of limits how we can, for example, use it. It's also upservice and AKS specific, so it currently understands those workloads. I don't know if it does generic things, but basically there's an alternative if you have enough access. So if you do VS Code and Copilot or whatever is your poison, then basically, and if you have your personal identity that you log into the Azure, it has read access to certain places, then you can actually do similar things with that one. So you can do, for example, firewall investigations. You can do setup of something like this. Let's not go into details, but maybe this that I hopefully blacked out everything important. So basically this is an example where I asked it to perform an investigation in firewall to see if any SSA traffic to outside internet is blocked. And it actually does it pretty well. It does a nice report, and it actually is a real use case where up team didn't have to debug that, but basically they get that one as a free from platform, which is probably the only time they've gotten something free from us. But I think the next speaker is probably coming up. So from my part, thank you. I hope the speedrun was fascinating, interesting, maybe even funny from time to time.